Okay, welcome everyone. Thanks for coming. This is the week 10 webinar of the class. We're almost done. So another around 2 weeks left, 2 weeks and a couple days maybe. And then we'll be done with the class. So just to let you know, the plan today, as always, I'll answer any questions that you have. So please feel comfortable asking questions. Then after that, we're getting into chapter 12, which is one of the most, maybe the most useful chapters or used chapters of the whole course. It's a biggie, and you've seen it, but you probably haven't seen details. And that is regression analysis. So I'm going to talk about the details of regression analysis. So we'll look at scatter plots. Then we'll look at what's called R. Then we'll look at what's called R squared. Then we'll look at the equation of the regression line. Okay, and we'll talk about the slope and the y-intercept. Okay, because it's a line. And how do you interpret those things? Then I'll remind you that you should never, ever, ever use regression analysis to talk about a cause. And not just regression analysis, pretty much stats. Stats is not about cause and effect. Okay, I've noticed a lot of you kind of accidentally put the word effect or cause in, and that's not what this is about. This is about relationships, about how as one goes up, the other tends to go up or is predicted to go up. We'll talk about that. Then as I promised, every week we do hypothesis testing. So part of regression analysis is doing a hypothesis test to find out if it's useful or not. And it'll be a hypothesis test for what's called rho. So that is the plan. I wanted to remind you this is week 10. What's important about the number 10? I ask you this every other week. Yeah, it's an even number, and even numbers, there is an exam this week. So don't forget by Sunday, have your exam done. I recommend by Saturday. There's no reason to wait till the last minute. I get emails on Sunday night. Hey, I want extensions too late. No extensions. If you let me know Friday, that's different, but don't wait till the last minute because that doesn't work. So again, we do have an exam, and just like we've been doing all the way through, the exam is cumulative. So it can cover anything from the first week of class all the way to now. There's more emphasis on week 9 and 10, but there is stuff on all the other weeks. So make sure that you're ready for all that. So there is the exam, and then a week from Sunday, your project is due. So it's important to, get moving on the project. I want to mention some of the mistakes a lot of people are making in their ideas for projects and what their plan was. First thing is imagine the survey question or the data you're collecting, and the data you're collecting has to be numbers. Okay, you can't do a yes no question. That's not okay for this project. And you also have to do a comparison between two samples. Okay, not a sample in a population, but two samples. So it could be two groups, men and women, for example, or college students and non-college students. It could be two places, could be temperature in Tahoe and temperature in Mammoth. I don't know. It could be lots of things, but it has to be two different things at which you don't know the population and can't get the population for either of them. If you can get the population without too much hassle, then the project doesn't work either. Just let you know that. So that is important. A couple more things. I'm just kind of mentioning the things that I mentioned on the discussion board when people put their ideas. In terms of the project, don't forget that you choose the level of significance based on the ramifications of the type 1 and type 2 error, not just the definitions, but how is your client going to be hurt if a type 1 error happens? Okay, not what is a type 1 error, but how is the client going to get hurt? How is the client going to get hurt if the type 2 error happens? And very important. And then if type 1 is worse, you choose point 0, 1. If type 2 is worse, you put point 1. And if they're pretty much the same in terms of how much pain the client is going to have to do and explain the pain that the client will go through, um, if they're about the same, then you use 0.05. So that's just a note. Another thing is the confidence level has nothing to do with any of that. Okay, what you're going to do is you're going to look at a 90% confidence interval, very easy on the computer. You can use a spreadsheet to do that. You can use a 95%, and then you're going to look at a 99%. For each of them, talk about the pros and cons of each of them. And then based on the client's needs and looking at the pros for the client and the cons for the client, which is going to be the best. And that's what you choose after looking at it, not in general, after looking at it. So that's one of the last things you do on this project, not one of the first. Okay. Whereas the level of significance, that's one of the first things. Okay. After you write down H naught and H1, then you think about level of significance based on type 1 and type 2 error ramifications. Any questions on that? Figured I should mention that because that's really important. A lot of people got confused when I looked at you know, your posts on the discussion board, on the Project 2 discussion board. Okay. And I'll keep looking, by the way. I watch every day. The only time I wouldn't watch is if for some reason we have a blizzard and I don't have any internet and then I can't do anything. Hopefully you'll understand that. We did have snow this last night, but not enough to cause any problems, fortunately. So, any questions? Okay. We don't have a giant group here, but I have a survey question for you. It's two survey questions. And the first is, how many miles have you ridden a bicycle in the last month? And the second is, how many miles do you live from your college? Just make if you don't know exactly, just make a good guess at it and put it in the chat box. So first question, second question, you can put the number, comma, the next number. And I want to put the data in. We don't have a big group, but at least there's a little bit. So I want everyone to put in how many miles they've ridden a bicycle in the past month. You should have two numbers. One is miles of bicycle and the other is miles from the college. So we have a 0, 5, 0, 8, 3, 9, 5, 7. Okay. And 0, 60. Well, you're far from college. Okay, so what I'm going to do is I'm going to put it in a different way. I'm going to write 0, 0, 0, 0, 3, 0, 0, 3, 5, 0. And 5, 8, 9, 7, 60. Okay. All right. Now, what I'm not interested in is, do you ride more than the distance you live? It's more what we want to say is if you know how many miles someone drove on their bicycle, can you predict how far they are from their college? Does that make sense? Okay, it's not about a difference between two means. That would be totally a different kind of question. And you probably wouldn't be very interested in that at all for this one. But you might say, hey, if someone lives far away, then maybe they are on a bicycle more. If someone's closer then to the college, maybe they're on a bicycle less, or vice versa. We don't know. Is there any relationship between the two? Does that make sense? So we're going to do what's called regression analysis. And There's a lot of math, a lot of calculus, which we're not going to touch. But hopefully, if we can't do the math and the calculus, what should we do? Oh, did I forget one? Oh, 0.26. I did miss one, didn't I? Let's see, 0.8, comma 26. There we go. Sorry about that. Okay. So what should we do? If we want to see if there's some kind of relationship, if we want to do regression analysis, any idea? If the math is too hard? Not too hard for me, but it's too hard for probably most of you. Maybe all of you, I don't know. No one's saying it? Yeah, we go to the calculator. So, which calculator do you think we want to use? Yeah, 25. You'll notice, by the way, there's only 26 calculators I made, and we're almost done. This is the second to last week. You can guess what we're going to do next week. But right now, we're doing regression analysis. And there's just one calculator for the week, but it's going to do a lot of stuff. And you could do it by points. It's a little faster the way I've got it to do it by data, as in separated by commas for the first group. And you have to make sure the order is all correct. That's really important with this. And let's do the second group for the Y. Any questions so far? And then I hit plot points. Okay. And what this gives us is a scatter plot. Okay. So what this scatter plot is, hopefully you're used to an XY axis, right? This is the XY axis. And what we've done, or what the calculator has done for us, is it has plotted all the points in the XY plane that you all put in as where X is how many miles you run a bicycle, and Y is how far you are, how many miles you are from your college. Does that make sense? So notice we have all these points. So the first one, for example, was 0, 5, and you'll see it's plotted right here, 0, 5. This is called the scatter plot. I do want to let you know this is a small sample. You would never, do this small a sample and say, hey, I have great information that I can do all kinds of stuff with. But, it's all we've got. And also, if we had a sample size of, 40 people, then it would take a long time to type in. Okay. I mean, in the real world, you do that, but not for a short web app. Then we also have a line. Any idea what this line is? Any thoughts? So we have this line that's kind of going down. Any thoughts of what the line is? Okay. Slope is a number that is part of the equation of a line. So you're right that slope is part of this line. But maybe I'll explain what this line is. This line is the best fitting line of these points. So kind of what you do is you say, well, for example, here's a point right here. This point here at x equals 3. And you look at how far up you have to go, okay, or or down. So it's an absolute, it's distance between the point vertically to the line. And it's not far for this guy, but for this one up here, the 60, it's a long way down. Do you see that? But if you look at all possible lines, in a way, it is the line of best fit of the points. Any questions on that? Okay. The line has an equation. Here's the equation. I'll get into that kind of detail a little later. There's going to be a hypothesis test. That's much later. Then there's R. Okay. R actually is a letter that represents correlation. You've probably all heard the word correlation and how correlated things are. And R will tell you how correlated, what is the correlation between them. Now, here R is negative, and that has to do with this the slope of the line is negative. So what that tells you is that as the distance that the amount of miles people rode on a bicycle increases, there's a tendency for their distance to their nearest college to decrease or to the college decrease because negative means as x goes up, y goes down, right? Because rise over run. So if you run one, you rise downwards if it's negative. Positive means as one goes up, the other goes up also, tends to. Any questions on that? Okay, so this calculator does everything you need. So R squared is also kind of considered, we call that the R squared correlation, and we call that R squared. And I'll get into the details of what that means also. So notice R is negative. So R really tells you as one goes up, the other tends to go down. R squared is never negative. And hopefully you know that from math. If you square something, you never get a negative number. Do y'all know that? If you square a number, a real number, you don't get a negative number ever. So R gives you that positive negative idea. R squared gives you idea of, it turns out how close it is to one. Okay, if it's close to one, then that means that knowing the number of miles that people have driven on their bike is a good predictor of the number of miles they live from their college. On the other hand, if R squared is close to zero, then knowing how many miles they have ridden on their bicycle is not a very good predictor of how many miles they live from their college. Okay, so that's kind of the difference, and I'll get into more detail as we go. Okay. There will be a test statistic and a p-value, but that's later. Okay, so that's the idea of all this stuff. Any questions on kind of looking at the calculator? So R is about, I'm going to go 2 decibels, probably good enough, 0.40. And R squared, you really want 2 decibels, 0.16. You should always round. Any questions so far? Okay. So I'm gonna have to change this. Remember, I didn't know what you guys were gonna, how far you live from college and how many miles you rode on the bicycle. So I made stuff up, and I'm gonna adjust. Okay, we got to interpret R. If R is positive, negative 0.40. That was my mistake because R was negative. So since R is negative, that means as the miles driven or ridden on your bike goes up, people tend to be closer to their college. So, but 0.40 is not that high. Okay. We can say for college students, so let me write 0.40, negative 0.40. So for college students who have ridden their bike a lot of miles, okay, there's a tendency for them to be closer to their college. But since the correlation is close to zero, it's not a good predictor. Any questions on that? Notice this word tendency is very important. You never would say students who ride their bike a lot of miles live closer to their college. That is false. You can only talk about a tendency. You can't say, hey, if someone moves closer to their college, they're going to ride their bike a lot more. You can't say that either because that's a causation issue. Okay? We only can talk about tendency and relationship. You cannot talk about causation. Any questions on that? It's actually, I would say, the number one error that people make in the real world in statistics is they do regression analysis and they think it tells you about causation. Yeah, make sure you use tendency. Okay. You can say predicted, tendency. Those are fine words, but not cause or will. Does that make sense? Okay, now let's look at R squared. Just note, mathematically, R squared is really easy because R squared is the square of R. And by the way, this is an easy one. Usually it's pretty hard but this one rounded nicely. And negative zero point 0.4 squared, 4 squared is 16, right? So negative zero point 0.4 squared is 0.16. That's how this came about. So very easy in the calculator, it turns out. R is very hard to code in the calculator, but R squared, once you have R, is simple. Okay, but here's how you interpret R squared. Okay, and this is a template. Okay, basically. There is a large variation. Okay, variation in statistics can also be thought of as a standard deviation. Okay, don't say variance. Variation or standard deviation is what you should say. On the number of miles students live from their college. Okay, students were all over the place. So if we look, there was this lowest number was 5 miles, and the highest number was 60 miles, right? There's a big variation in the number of miles students live from their college. Do you see that? If you look at these numbers. But if we only look at students who all have ridden their bikes the same number of miles in the last month, then this variation on average tends to decrease by 16% because R squared is 0.16, which is 16%. So this kind of helps understand how to interpret R squared. So it allows you to just have a much better feel for the Y value if you know what the X value is. Doesn't mean you know exactly what the X value is, but if you look at the cluster of numbers for the Y value that are all fixed at a fixed X value, that cluster is going to have a much smaller standard deviation, or in this case, only a little bit smaller because 16% is not that much less small. So this actually is a very small, we just say a very small correlation. It's not a large correlation because 16% isn't that much of a drop. Any questions on interpreting R squared? Any questions? Okay. So here's some important things. Okay, so R is called the correlation. That's the word for R. And you've heard that word, but you may not have seen the letter R and what it's all about. In our class, I'm not going to tell you how to compute it mathematically. I'm only going to show you on the calculator that it does it for you. But if you want to learn, take my vector calculus class, which is like, a lot of calculus classes, by the way, and then you'll learn about it. It's pretty intense. Okay. R is never greater than 1. It's never less than -1. It's always between -1 and 1. Okay. The sign of R, whether it's positive or negative, is the same as the sign of the slope. So if you have a negative slope, R is negative. If you have a positive slope, R is positive. Okay, if R is close to -1, then the points are all close to being on a negatively sloped line. If R is close to 1, then the points are close to all being on a positively sloped line. If R is close to 0, then there's no line that fits the points well. Okay. So by the way, the kind of a typical, I like to visualize this, although if you live in a city, you may not even know what this looks like, but um, on a clear night in Tahoe, at least, I look up at the night sky, okay, especially now where the moon's not out, and the stars are all over the place, right? They're not sitting on a line. There's no line of there's no line of best fit. They're just all over the place when you look at stars, right? They're all over the sky. Okay. So R, if you look at kind of the, X and Y, that might be kind of like east west versus north south. Then R would be really close to zero because the points are all over the place. They don't just sit on close to a line. Can't even imagine a line that they sit on. I mean, there's some stars that are close to a line, but if you look at all the stars in the sky, no. Does that make sense? Any questions on the idea of R, the correlation? Okay, so here's a question for you. Put in the chat box. Think of a real life example of two survey questions. Okay, that could be measurements too, where R equals one. And remember, if R is close to one, the points are all close to being on a positively sloped line. If R is one, they're really on a positively sloped line. Can you think of two survey questions where you get R equals one? R is exactly one. Put it in the chat box. Give you a minute or two. If you're watching this on YouTube, then see if you can write it on paper. So think of two survey questions where the correlation will be perfectly one. And put it in the chat box. Give you a minute, but it's important that you all try. Do your best. Hopefully you can come up with something. There are a lot of good examples. Okay, let's look at one. How many hours a week do you spend studying? How many minutes a week do you spend studying? Perfect. Perfect. Because if someone spends 3 hours a week studying, we have a perfect prediction. Then if they spend 3 hours a week, they spend 180 minutes. So they all lie on that line, y equals 60x. Because if you're given the hours, you multiply by 60, and that gives you the minutes. Okay, so when you have R exactly 1, that means there's going to be an equation. There's going to be a formula that tells you how to get from one to the other, and it's perfect. So great example, wonderful example. Any questions on that? Okay, now let's look at the same idea. Okay, and by the way, I have one also. How tall are you in inches, and how tall are you in centimeters? Okay, that one works also. Now let's see if you can think of a real life example of two survey questions where R is very close to zero. To get exactly zero, that's impossible pretty much, or almost impossible. But two survey questions where R is very close to zero. Let's see if you can put in two survey questions. It could be two observations. Yeah, often two observations happen. How many hours of music do you listen per week? And how often do you eat breakfast at home per week? Okay. That one may be close to zero. It may not actually. Okay, because it might be that if people have more time to listen to music, they're probably at home more. Does that make sense? That's possible. Okay. Now it might be the other way around. Maybe if they listen to music a lot, that means they're in their car a lot and they're, have a long commute or something. But again, I'm not sure. But I'm not sure if that would be zero. Does that make sense? There's probably a correlation between those. Okay, let me give you an example, and hopefully you'll agree that these wouldn't have a correlation. Okay, the first would be what is the temperature in South Lake Tahoe? And the second is what was the total number of points in the soccer game that last got played in New Zealand? Okay. If you know what the temperature is in South Lake Tahoe, does that give you any idea or clue about what a total number of points in the last soccer game in New Zealand is going to be? Yeah, no idea. They have nothing to do with each other. Does that make sense? Okay, at least I can't imagine them having anything to do with each other. And if they have nothing to do with each other, then you get R really close to zero. Does that make sense? Okay. On the other hand, if it's the same thing, person doing two different things, there's often a correlation. Does that make sense? Not always, but often a correlation. Okay. It may not be 0.99, but there's won't be that close to zero usually. Okay. See if you can come up with an example where the correlation is close to -1. You can type in the chat box. I'm hoping all of you can, not just one person, but all of you can come up with an example where the correlation is very close to -1 or even exactly -1, but close to -1's fine. And there are lots and lots of examples of this. Let's see if you can come up with one, which would be like two survey questions or two observations. It's really important that you understand how these work. Hoping you can all come up with something. I'm watching the chat box. I know it takes a little typing, but it's not too bad. See y'all jumping in. I'll give you another minute or so, but okay, hours spent on your phone and the amount of homework completed. Okay, that's probably pretty good because if you are always at your phone, then you're probably just not even thinking about doing homework. Okay, so more hours on your phone, you're probably going to complete less of your homework. That's a good one. That's a good one. Does that make sense? Okay, so now what I have, by the way, is how many cigarettes a person smokes each day and how long they live. Okay, correlation's not exactly -1, but hopefully you all know that if you smoke a lot every day, then there's, a chance that you're going to die younger. Do you all know that? I hope so. Okay, it's good to know. It's smoking is not good for the health. Okay, it doesn't mean that everyone who smokes is going to die young. So, but it means that there is a tendency. Okay, so just to let you know, R squared is the square of R. I mentioned it. I recommend making R squared a percent instead of a decimal because it's easier to understand what it's talking about because it gives you the percent of the variation. Okay, so the variation in the y variable is considered very large. But if you just look at the y values that all have x values that are almost the same, then on average, the variation is reduced by that percent, the r squared percent, written as a percent. So this is a template, and yes, you do need to somewhat write it in this way. Okay, so that is required. If you use AI, it won't write it in this way. And of course, but don't just copy and paste this exactly because it's too vague, because it'll be about one thing or another. It might be that if, the variation in the amount of how long people live, it's pretty much okay. But if you only look at people who all smoke the same number of cigarettes every day, then the variation of that group will be reduced by r squared percent, whatever that percent is. Might be 40%. Does that make sense? So that's your template. Okay. So here's another example. I have lots of examples. Okay. We're just doing regression analysis today. So examples are important. Okay. You could look at the city of population size in thousands versus a crime rate per thousand. And R is equal to negative 0.36. Okay. Negative 0.36 is closer to zero than to negative one. So we're going to say there's a weak correlation, but that correlation is negative. So there's a weak negative correlation between city size and crime rate. Okay. Any questions on that so far? Okay. We can also say you can square negative 0.36 and you get 0.13. If you square it, stick it in your calculator. That's about 13%. So there's a large variation in crime rate from city to city. But if we only look at cities that all have the same population size, the variation in crime rate is reduced on average by 13%. Do you see how that template works? Any questions? All right, so now I am going to go over what I consider the most important regression analysis that's ever been done in Tahoe. Any guess on what that is? Now, if you know nothing about our town, our area, then you're not going to guess. But if you live here, you probably know. Has to be with the lake, yes. Okay, so let me give you a little story. This is really cool. And I actually heard about it from my student. She was actually worked in the hotel restaurant and she served food to the President of the United States and to a bunch of Congress people who happened to be in Tahoe to talk about environment. Okay. This was the year 2000. Okay. So it was a long time ago. Okay. Um, and anyone know who the president was? This is not a math question. Anyone know? Yeah, Clinton. Okay, one thing you may not know about Clinton, and this is something that to me is really important about a president, is Clinton understood statistics. I think all presidents should understand statistics so that they can really see what's going on and understand science and statistics and what they can trust and what they can't trust. And statistics really help you out with understanding how much you can rely and trust something. So the UC Davis, the Environmental Research Center, came and presented. And let me show you what they presented. This is the picture they gave. Okay, so even says UC Davis if you may not be able to read that, but that's what it says. And what they did is they went and they had measured over the years since 19, I think it was 68, might have been 67, the depth of clarity of Lake Tahoe for each year, all the way up again until around the year 2000. They had done this, and that's why they presented it. Okay. If you look, this is a scatter plot. Okay. And if you look at this, does it look like there's a correlation between year and depth of clarity? What do you think? Or are these points all over the place? Does it look like there's a correlation? Okay. Hopefully you think it, you realize that, yeah, these points are not all over the place. You can imagine that line. Okay. Here's a trick question. Is the correlation positive or negative? Okay. So you may not have heard the one of the words I used, trick question. Okay. This is tricky because you'll notice that this right here at the top is 0 and the bottom, like down here, is 35. So the y-axis is upside down, so you got to like flip it. So even though it looks like the line of the slope is positive, but it's upside down, so it's negative. And that's a trick question. But they wanted to make it look like Lake Tahoe. What I want to do is I'm going to take the data and copy it. I'm going to refresh the screen. That's the easiest way. And then I'm going to paste. Okay, notice these are all years, 1968, 69, 70. And what I did just to make it a lot easier, because I didn't want to type in 1968, 1969, 1970, I'm just going to go year since, number of years since the year 1900. So 99 would be the year 1999. Okay, and since they were presenting this in the year 2000, they didn't know 2000 yet, because it wasn't over yet. So they went up to 99. And then I'm going to do these numbers, which is the depth of lake clarity. And what they do is they take what's called a Siki dish, which is just like a plate, and they drop it down in the water until it disappears. And then they see how long that rope was when they dropped it, how deep it was, and that's those numbers. Okay? And these are in meters. And we're going to put that into the calculator. And I'm going to hit plot points. Okay. And now it's not a trick question anymore. Hopefully it's very clear that the slope is negative. Is that clear now? Much easier when it's done in my calculator. But you don't get to see a boat and stuff like that. Okay. So easier mathematically understand, but harder in terms of like seeing the lake. Okay. And now what we have is we have R is negative about 0.85 and R squared is about 0.72. Remember, always round. Okay, any questions on that so far? Okay, so now we can use that. Oh, we also have the equation of the line, which is about 45.6 minus 0.247x. So 247, I thought so. Any questions on the equation of the line? If you want, you could also write that as negative 0.247x plus 45.6 if you want to write it as y equals mx plus b. So works either way. There's a reason to write it this way, but it's too complicated for me to explain in this class. All right. Now, who remembers what the slope of this line is, how to read it? What is the slope of this line? It's really easy if you remember. What's the slope of the line? By looking at the equation, you should be able to just quickly type it in. What's the slope? So if you put in the chat box, what's the slope? Just want to make sure you all remember how to read the equation of a line. You can also look at it this way, but same thing. What is the slope of the line? I don't see y'all putting it in. Do you remember the slope is the number in front of x, like mx plus b? Do you remember that? So the number in front of x is negative 0.247. Okay. And then hopefully you all remember the slope is the rise over the run. Do you remember that from like eighth grade, maybe ninth grade, depending when you had it? Do you remember that? That was the slope was rise over run. So the slope of a line is rise over run. Rise is how much y changes. Run is how much x changes. Okay. Because it's usually in decimals like that, our slope, let me round it to 0.25 because that's what I did earlier. And 46. I'm going to round it a little nicer. So the slope is negative 0.25. Now notice we can rewrite that as rise over run. If you want to write as a fraction, you can always write it as over 1. You can always put a number over 1. Negative 0.25 over 1. So the rise is negative 0.25 meters of clarity in the lake. The run is 1 year. Okay, because the run is the x-axis, and that was years. The rise is the y-axis, and that was meters of clarity. How far down you can see that disk. So now we can interpret the slope. We say for every year that passes on average, the lake clarity has tended to go down because it's negative by 0.25 meters. Any questions on interpreting the slope? Okay, any questions? Okay, so that again, if x is increased by 1 unit, that's the same thing as for every year that passes on average, passes, then y is predicted, and that's the clarity is tended to go down by 0.25 meters. Okay, the y-intercept, okay, notice the y-intercept is this value 46. Okay, and that is the value when x is 0. But it's really important. You look at the years. Are any of these years close to x equals 0, which would be 1900? And is 0 even in the realm of these years? What do you think? Any thoughts? You look at all these numbers. Are any of these numbers anywhere close to 0? Because they're 68 to 99. Yeah, none of them are. Okay, if 0 is not even in the realm of your data, nowhere close to it, then it turns out that there's really nothing to interpret. It doesn't really have any like real meaning that will tell you about lake clarity. Is that clear? Okay. If 0 was in the realm, then it would be your best prediction for the year 0 or the year 1900. But since it's not that close to it, then no. So y-intercept is sometimes useful, but other times it's not. So if the number's not even in the realm of the data, it's not useful. The other time it could not be useful is if the number doesn't even make sense. So if you got a lake clarity of, if you got a y-intercept of -20, then that's silly because you can't have a -20 meters of lake clarity. Is that clear? So if it doesn't make sense to even say that x could be zero, I mean that x could be zero, then don't go there. Or if it doesn't make sense to say y could be whatever that number is, then don't go there. 46 could happen. You could have a lake clarity of 46. Okay, 46 meters. Okay. If you don't know Lake Tahoe is very deep. Okay. If it was only, 40 meters deep, then 46 would be useless because you can't see 46 meters if it's only a 40-meter deep lake. But Lake Tahoe is a really deep lake. Okay. It's the bottom of Lake Tahoe is actually lower than Carson City. That's how deep it is. I think it's, if I remember, the second deepest in the country. It's really deep. Okay. So here, it doesn't really have great relevance. Okay. You would say our best prediction for lake clarity in the year 1900 is 45.6 meters, but since none of the data is anywhere near 1900, this is not a good prediction. Any questions on that? Okay, what's the best prediction for the lake clarity in this year, 2025? How do we make a prediction? This is actually not that hard. Any idea how you would make a prediction for lake clarity in the year 2025 based on the data that we had? Okay. I don't see y'all jumping in. What you would do is you'd say, well, 2025, that's 125 years after 1900. So that means X is 125. So all you have to do is you go back to your equation and plug in 125. And you're always allowed to use a calculator. So I did that. Okay. And I took kind of these long numbers, 45.6155 minus 0.2465x. I put in 125 and I got 14.8. Okay. Okay. Just let you know that, in 1999, the lake clarity was 21. In 1968, the lake clarity was 32. If the lake clarity went down to 14.8, would we be okay with that? Especially those who live in Tahoe? Would you be okay if that was our lake clarity? What do you think? Because one of the things that's so wonderful about Tahoe is it's such a beautiful lake. Okay. All right, I don't see anyone say I would not be okay because that would mean it's just murky and gross. You look down and you can hardly even see down. Okay, compared to what it is right now, compared to what it was then. Okay, so based on this regression analysis, okay, the Senate, the Congress people, and the President of the United States passed a law, okay, and put in money and science so that this didn't happen. Any questions on that? Okay. But one of the things you also want to do, and just by the way, here's some words to avoid in all regression analysis. One is the word causes or cause. And just to let you know, you may not have even thought about this, but the word because, the last part of the word because is cause. Don't use that word either. Because is the cause word. Don't write if something, then it will. That's not okay either. Okay, those are words to avoid in any kind of interpretation in regression analysis. Okay, now we're going to do a hypothesis test. And the hypothesis tests, the good news for our class, at least, just for our class, is that it's always going to have the same null hypothesis and it's always going to have the same alternative hypothesis. Okay? H not colon, you're used to that. This is a Greek letter. Anyone know how to read that? Anyone know how to read that Greek letter? Okay. I don't see anyone popping in. The way you read this is rho. Okay. The way you often spell it is RHO. That's how you like spell it in English. I like to think about it as row, row, row you boat because we're talking about Tahoe, but it's not just for Tahoe, by the way. It's for any regression analysis. And what it is a population correlation. And H naught is that there is zero correlation for the population. So rho equals zero. H1 is that the correlation is not zero. Rho is not zero. If rho equals zero, then regression analysis is totally worthless. Because if rho equals zero, then knowing what x is gives you no information about what y is. Okay, if rho is not zero, then you get some information. Remember, you get reduction. That means that the correlation is not a zero correlation. So one thing is that you get a better predictor if you know your x and you want to predict y. So in particular, for our example, for the lake, we have a test statistic. It turns out, again, the math is really hard. I can't get into it, but it turns out you can use the student's t-test, the student's t-distribution, I mean, and um, the test statistic is negative 8.7 or so. By the way, is the p-value 9.67? Yeah, it's not. Don't forget, read the right-hand side, e negative 10. If you ever see a number 1 or bigger than 1, if you ever see a number bigger than 1, that is usually means a scientific notation. Okay? So this is scientific notation. So it's about 9.67 times 10 to the negative 10th, which is tiny. So in particular, that means it's going to be 9 zeros before the 967, 0.0000000000967. Okay? That's like as strong evidence as you could even imagine, right? Such a small p-value. So we can say there is very strong, statistically significant evidence to support the claim that there is a correlation between year and lake clarity. Any questions on that? Any questions? Okay, so again, I'm going to say this again because it's so important. Do not use word cause. Don't use because. Don't use if, then, it will. So let me give you an example where you really can't talk about correlation, or I mean causation. So for example, let's suppose that you looked at the percentage of a person's hair that is gray for one variable, and you looked at their age for another variable. Do you think those would be correlated? What do you think? If you look at the percentage of gray hair versus and age as the two variables, you think those variables would be correlated? What do y'all think? Yes or no? What do you think? Put it in the chat box. Hoping you're all paying attention. Not seeing you. Hopefully you can hear me. Otherwise, you probably would have put something in the chat box about not hearing me. Okay. Okay. What do you think? Do you think the percentage of gray hair as the X variable and age as a Y variable, would those be correlated? Okay. Yeah, the answer is definitely they're going to be correlated. Okay. So if you see someone and they have more gray hair, then you would predict that they would be a little older. Does that make sense? Does that mean that if somebody who had gray hair and they dyed their hair brown, that's going to cause their age to go down? What do you think? No, definitely not. Okay, there's no causation in that. Do you see that? To go from percent gray hair to age. Percent gray hair does not cause age. Okay, in this case, it's the other way around. Age can cause gray hair, but gray hair doesn't cause age. Does that make sense? So sometimes the causation's not there because it's the opposite direction. And then sometimes the causation isn't there because something else is causing both. Okay? So that can definitely happen. Okay? Where you have one thing cause two other things. But if that one thing isn't there, they're not going to cause each other. Does that make sense? Okay. Can anyone think of an example of that? Two things that are correlated, but there's no cause in either direction because they're caused by something else. And that can definitely happen. There could be a third thing that causes everything. Okay. How about let's look at how many tears come out of a child's eyes and how sad they are. Okay, something is going to cause both of those, the sadness and the tears. Does that make sense? So that's a possibility. There's a lot of different things. Okay, I want to show you something really important, and that is this was the original picture till the year 2000. And I want to show you what do you think if you were the Congress and you were president, you would make that change because you don't want this to continue happening. Let me show you what happened recently in terms of our lake. Look at this now is the graph or the scatter plot of Lake Clarity of Lake Tahoe. Look what, after the year 2000, remember the year 2000 is when that big bill was passed, because that's when the president and Congress found out about this environmental disaster. And then past 2000, what do you notice about these points? What do you notice about the scatter plot after the year 2000, from 2000 to 2020? This is, I think, goes to 2024 or so, maybe three. What do you notice? Yeah, all of a sudden, there's no correlation anymore. Okay, all of a sudden, you don't see the points going upwards in a predictable manner anymore. They're still up and down. Why do you think there's up and down? And this is actually really important in regression analysis. And notice there's even up and down before. Do you see that? There were years of up and there's years of down. Any guess on why there's years of up and years of down? Even when we didn't have environmental protection? Do you know why there's up and down? So there's still a standard deviation. It's not as high as long-term standard deviation, but there's still a standard deviation. Okay, so let me tell you, weather. Okay, big rainy, snowy years, we get more stuff going in the lake and you lose clarity. Whereas if you have a light, not much snow and not much rain, then our clarity is going to get better. And that has, you can't, nothing to do with what year you're in and how, whether you're far from the 1900 or close to 1900. Big rain, snowy years happen and big rain, snowy years don't happen. Does that make sense? So often there are multiple things that are part of the causation. And that's why you're still going to have some variation, but the variation is going to be reduced if you just look at a year or a cluster of years in an area. And this is great news right here because now our lake is not getting worse and worse. So that's the good news. Any questions on lake clarity? Okay, we have some time, so let's do a few more. Okay, let's look at years of successful education after 10th grade and salary. Okay, you've probably heard this one before, in thousands of dollars at age 30 years old. And they did a study, and here we go. This person had 6 years of successful education after 10th grade, and they made $75,000. This person had 2 years of successful education after 10th grade, and they made $18,000, etc. We could do the same thing. Could pop it in. I'm going to hit refresh. That's the easiest way. And then I'm going to pop in my new data. And I can hit plot points. And is there a correlation or not? What do you think? What do you think? Is there a correlation? You should know just by looking at what we just got. So yes, no, yes, there's a correlation. No, there isn't. Yeah, there's definitely a correlation. Look at the scatter plot. It should be kind of clear. Okay. As the years of college education goes up, salary tends to also go up. It doesn't mean it always goes up. Like from this point to this point, it went down. But it's a tendency. Also, our R is zero point 0.9, which is a strong correlation. 0.9 or higher, you usually call strong. Okay. And then R squared is about 0.82 or 82%. You can have a hypothesis test. Our p-value is 0.0001, which is also very small. So yes, there is statistically significant evidence that there is a correlation between how many years people have gone to college and what their salary will be in when they're 30 years old. Any questions on that? Okay. So again, here we have, there's a strong positive linear correlation between the number of years of successful education after 10th grade and the salary at 30 years old. We can also say there's a large variation in salaries at 30 years old, right? You look at this and at 30 years old, we got someone making 18,000, we have someone making 220,000, here's someone making 10,000. They're all over the place. Do you see that? So there's a large variation in salaries at 30 years old. But if we look at 30-year-olds who all had close to the same number of years of successful education after 10th grade, then that variation on average tends to be decreased by 82% because R squared is 0.82. Do you see how that template works? And yes, you do need to write the template. You'll lose points if you don't. Use this template idea. Okay. We saw that the regression line was y equals about, negative 0.27, etc., plus 16.4x. Okay. And if we look at this, now we can use a line. Let's use a line at x equals 6, interpret it for a complete sentence. If you plug in 6, you get 71. So our best prediction for someone with 6 years of successful education after 10th grade is that they'll earn a salary of $71,000. Any questions? I've gone kind of fast because we've now seen like all the details and now it's time to just do examples. Okay. The slope was 16.4. Let's interpret it. For every additional year of education after 10th grade, on average, the salary tends to go up by $16,400. Okay, because this is in thousands of dollars, by the way. Okay. If you said every year of education will make your salary increase by $16,400, you're going to lose a lot of points because that's a causation way of saying it. So it's really important you use the non-causation way of saying it. Okay, the y-intercept. Okay, so now the y-intercept here is negative 27.34. By the way, can you have a salary of negative $27,000? Can that be your salary for your job? What do you think? Yeah, no, you can't make negative 27,000. That's not a job. That's not a job. Okay. You could pay for your house for that, but that's not a job. So because of that, can't even make negative salary. The y-intercept has no relevance. Any questions on that? Any questions? Okay, so hopefully you understand how important this is. This is used not just for lake clarity, it is used in so many applications. There are so many applications where you want to say, hey, notice that if this tends to go up, then this tends to go up. Or this tends to go up, this tends to go down. Let's make a prediction of what's going to happen if this happens. Okay. Be careful about the word cause. It's only predictions. Does that make sense? So regression analysis comes up a lot. I'm sure you've all seen and heard about it. Doesn't mean you know the details, but you've all heard it, right? Of this kind of talking. Okay, it's really important. It's used for so many different things for making decisions. All right, so the secret word is tens, because that's a really important word to use when you're doing interpretations for, for example, for slope of the regression line. Okay, that word tens needs to be there. Okay, so that's the secret word of the day. It's a really important word. Okay, and hopefully you all understand how important regression analysis is. I can't say that too many times because it's so important. So it is 7:15. I know we're a little earlier than usual, but that's okay. I tend to go a little shorter towards the end of the course, a little longer at the beginning. There's less work at the end. And part of the reason for that is, especially if you're at our college, other classes tend to push you a lot more at the end and less at the beginning. So I go the opposite because you have more time at the beginning. Um, so we just have one chapter, for example. Um, but the one thing that you should be spending a lot of time on is this project. Okay. The hope is by, you know, maybe by Monday, by a week from today or so, have a draft done you can send to me. I do want to let you know one more thing that's important. There will not be a webinar next Monday, and there will not be a webinar next Tuesday. How come? Why is there no webinar at all? Yeah, next week is Thanksgiving. Next week is Thanksgiving. There's no webinar. Okay, there are no assignments that you have to turn in. I always say, do you know your homework next week? Your homework is to gain weight. You should eat a lot on Thanksgiving. Isn't that what we do on Thanksgiving evening? Is we eat. At least I do. Hopefully you do too. Uh, so I'll be at a Thanksgiving dinner. And so next week you're off. I will be checking, a little bit, not as often, but I'll be checking my email and discussion, but not quite as often as usual because I actually see family and do all the fun Thanksgiving things, and hopefully you do also. So the hope is that you'll really work on your project this week so that you don't have to do anything during Thanksgiving. The very latest possible, and I'll pop in the syllabus because that shows you. So a couple things. First thing, the project is due on December 7th. Okay. And the latest possible, according to what this says, is you must bring it or email to me at least by Thursday at 8 a.m. the week before it's due. Okay. So that time before it's due. So that would be December 4th, but better would be more like December 1st because that way I'll have time to read it. I'll be able to send you my feedback. You'll have time to work on addressing the feedback, and you'll be able to talk to a tutor and all that and get help. December 7th is your last possible day to turn it in, submit it on Canvas, the final, not the draft, but the final project. I recommend turning on December 6th because in case the internet dies or something, that way you're not screwed. So if you turn it in December 6th, then you get that extra time. Um, So that's my recommendation. Try to put on December 6th as your calendar today. And again, somewhere around like December, 1st or so ish to drop me an email with your project draft. And I'll tell you, it makes a huge difference because if I can let you know of all the things you need to change and you change them, your grade then it can go up. If you don't send me the draft, I can't let you know if things change because I haven't read your draft. And then the things that you need to change, you didn't because you didn't even know about them. And then you lose points on it. So the draft makes a big difference. And don't forget, you must have a partner to get a passing grade. Okay. So make sure your partner's still in the class, make sure they're still willing to work with you. Best is three people, less work per person. And also that way, if something happens to one of the others, you still have, enough. But three is always best. Any other questions? Really good questions. Okay, if there aren't any questions, as usual, I'm going to stop the recording. And then, as always, I can answer questions if you want to ask questions that aren't public or whatever. So let me stop the recording. Thanks for coming. Next week will be our last webinar. I mean, not next week, a week after next. Next week, there's no webinar because it's Thanksgiving. And then the week after next, I think it's going to be a Monday, will be the last final webinar of the class. And that'll be a little shorter, actually. So I'm going to stop the recording.